Welcome to our video demonstration of QUICKSURFACE. In this video I'm going to show you how you can bring in two scans of a broken part and then using our tools to create a cut model of the same part that is ready to be printed. So let's begin. I'm going to start with an empty project. I'll just save this to have it in the background and we'll open my first part in QUICKSURFACE. So that's the first scan, and then using the file import scan data I can add the next piece of the same part. As you can see, we brought them on the screen, and the first step that I'm going to do now is to align these pieces together. To make the workflow easier, I'm going to change the color of one of them. I can just select my piece, right click and choose a color. In this case I probably want to have something like this, and you can see it on the screen. The first step I need is to put the two pieces together. I will pre-select my handle of the part and I'm going to the option which is called Align, and we'll select Align Interactive. The reason I'm doing this is because I can just easily manipulate this on the screen, so I can get a better idea of everything, just to pull this part away of each other. There are different controls here. For example, I can rotate around the global world z-axis, or I can just rotate manually here on the screen. What I'm trying to do now is just to get a good view of the two sides of the meshes that they need to glue together, because I'm going to define a transformation from one part, how it can stitch to the other. This is good enough. I have a good view and I can press OK. I'm going to use the option which is called Align by Endpoints, which is accessible from the toolbar. And the main idea here is that you pick the same corresponding points on the two objects, and these will define our transformation and will bring one part to another. Let's begin. I pick roughly this point and I'm trying to get the same point on the other object. Clicking here, I take the second one, and this piece is probably here, and also I take this point here. Now, for the good practice, when you pick these points, try not to pick them in the same line. You need to have a better sparse in space so the transformation can be applied properly. For example, here I can just zoom in and pick this point, and probably this is my corresponding one here. You can see this piece matches to this one, and this is my fifth point. Here at the bottom I see some other points like this one. You don't need to pick only 3 points. The more you pick, the better it is for the transformation. Now these points are very well defined and I can press preview. You can always check the results, and this is what I get as a rough alignment of the one piece to another. And I can press OK at this stage. To save your work, it's always a good idea to save it on the disk, because working hard here, so you don't lose in case of crash of the computer and so on. I put these meshes together. The question is how well they are aligned, and in order to check my performance, how well I'm doing, I can just pick this mesh, and then what I'm going to do is select Analysis and compare to the other meshes. What I can see here, how close my alignment is against my reference mesh. This is a plastic part, and the tolerance is a bit high, so you can just choose this to be 50 microns or 0.1 millimeter, depending on your expectations. What you can see on the screen is the tolerance. You provide 50 microns, and everything which is closer than 50 microns will be colorized in green, and you can hover your mouse and see the actual deviation. In this case we managed to do quite a good job. But what else we also can do is the following. I can pre-select this part, and then I can go select to reference mesh, flip mesh normals. What it does, because it has sides, it actually will flip around the representation of the mesh. The reason for this is that one of our algorithms, which is called fine align, requires the two pieces that we align to be oriented in the same direction. So that's why I need to flip this mesh normals. Still, I have this mesh pre-selected. I can go to our last step, which is called fine align of the reference mesh. And here you specify the lookup distance between the two. The algorithm will take the active mesh and using the best fit will try to align as good as possible to our reference mesh. And you can see now it just prepares, and it didn't move a lot. The reason for this is because it tried to use a lot of the points in these meshes. And to make this better, I'm going to hide this now. We'll flip the normals so I can see what's going on. And we'll use our selection tools. The selection tools allows me to pick some points from the mesh just by simple brushing. And what I'm trying to do is just get this information that will be used for my alignment process. I'm trying to get only the points that actually have a big influence into this alignment, so I can get a much better gluing between the two surfaces. So I think I'm good enough. I can close this. Again, unfortunately, I need to flip the normals so to take the algorithm working, but the triangles are still selected, as you can see. And we'll show my base mesh, select my active mesh, go to align, and fine align the reference mesh. Now the algorithm will use only the selected points, and as you saw, it just moved slightly so it can get a better approximation and get closer to our initial reference. Let's go and flip the normals, and again I will unselect everything. What I'm going to do now is we'll pick this and make analysis of what has happened. If you remember, in our last step there were some other areas that were not within the tolerance, but as you can see now, this algorithm improved the quality and it matched the two pieces together. So I'm really happy with my results. I can show my piece. What I have now are the two individual meshes. I'm going to just duplicate every one of them by right-clicking and say duplicate. It just created another copy. We'll do the same for our second piece. The reason for doing this is just I keep my original information just in case I need it in the future. So now I have these two, but there are still two different meshes. What I want to do then is create them as a single mesh. The way I do this, using the control key, I select the two, I right click, and then I select merge. What merge does, it simply creates a single mesh out of these two pieces. It doesn't connect them, it doesn't create a new topology, it just brings them into a single entity. I'm going to save my project for now. Our first step is completed and we can start reverse engineering. I'll just place the object into our standard views. To place them in the standard views, you can use our navigation cube on the top of the screen, and you can pick the view from which you want to see. It's really important before you begin any reverse engineering to align your object. What alignment means is that we can take a look at the coordinate system, how it is positioned, and how our part is actually related to the origin, to the standard planes. Creating this is very important to create watertight and precise models that are accurate and they follow the design intent. How we can do this? Firstly, by analyzing what our goal is. You can use different approaches, but in my case I just try to understand how I can position this. Because this part matches to a different one, I think that this is the plane that is really important for me here, that it snaps to another object. And then also I want this cylindrical area to be perfect, so it can actually roll, and probably my other axis is in this direction. So how can I align? In order to do this, we need to start extracting our primitives. This can happen with the button which is available in the main toolbar, which is called Extract Primitives. The way we can extract the primitives is just by pre-selecting some areas on our mesh. And the first one is called Magic Wand, which is a case-sensitive selection. How it works is just click on the mesh, and based on the sensitivity between the neighbor triangles, it just expands the selection until the curvature changes. You can control this value just by dragging this slider, or you can just pick on another area, for example here, and then you can increase. Depending on the noise of your scan data, you can get a different result. As you can see, it stops here because this is kind of a different topology, so you need to click here, and you can just adjust your slider so you can get this information. This is probably our plane, and what we're going to do is just create our plane here. The software approximates the pre-selected points. The question is how good it is, and in order to see this, we have a tool which is called Analysis. If you remember, we were talking about 50 microns, and you can see how good your plane is. Because this is a plastic part and it's not perfect, you can get some damages here, but this is enough for me to say and accept this plane in the way it is. I can just press create, and the software will create this as a reference for me. Now I need to create my outer cylinder. I can probably hide this plane. I'm trying to get the selected area here through which I'm going to generate my cylinder. I'll place it in a standard view, something like this one. I can hold Alt key so I can rotate around the view Z axis, and I can use the arrow keys just to rotate by 90 degrees. I'm going now to use my brush because this is too noisy, and we'll make sure that select through is turned off so I can pre-select the area that are needed to define my cylinder. I will press the arrow key. You don't need to be precise, you just brush and make sure that you get some information out here. I can just rotate and pick a little bit more of this area. I want to analyze how good and how cylindrical this face is, and I can just press Fit Cylinder. Here instantly, because the analysis was on, I can see the quality of my center here. It's quite good. This is damaged, so I don't really care, but this is under 50 microns, so it's quite good for me to be as a reference. I can create this cylinder as well in my scene. I will close this for now, and I need to analyze what will be my other direction that will be probably my x-axis. For this reason, this is the direction that I need, or maybe this cylindrical part. What I need is actually to create this cylinder, but my problem in this is not a real cylinder here. So what I need to do is actually use the manual tools to pre-select the areas that will define my cylinder. I'm trying not to select these noisy areas here. I pre-select this one, and we'll rotate using the middle mouse button. We'll pick this area that it's also part of the cylinder, and I probably need to pick this area here, something like this. Unfortunately, to make a very good cylinder fit, you need to get points from most of the sides of the cylinder, so the algorithm can get and makes its best. And I can press our Fit Cylinder button. I can analyze my results, and you can see that it approximates pretty well where the cylindrical area is, but it fails. So because it's a plastic part, this is not very good, and it has been deformed, but this is good enough for my purposes. And I will create this cylinder in QUICKSURFACE. So what I have now is a plane, then I have a cylinder which has been defined here, that will be my z-axis, and then I have this direction that will define my x-axis. How can we align our object is by using the align, and then we have something which is called align by coordinate system. Now the way we extracted is this plane and the cylinder, so I'm not sure which one is the best, so you need to define the different features in different order. For example, in this case I will say it's really important for me the plane to be XY. Then I can pick this cylinder, and you see this became black because it found where the origin should be, but my x-axis is not in the right location, so I can pick this to define my x-axis. When I'm happy with this will be my coordinate system, how it will be positioned in space. I can just apply. When I apply this, if you notice, you can just check your strategy and what you have done just by clicking on the standard views, and you see that now the coordinate system is properly defined, and this is a good start for our reverse engineering. I have pre-aligned my part, but as you can see there is still a lot of difference here for some reasons, and it might be a good idea that you, let's put the coordinate system, it might be a good idea that you do some manual adjustment. For example, I can go align interactive, and here I can just use my numeric buttons to align this exactly where I need to. For example, if you want, you can rotate this. This is really important where the center and the origin, and what I'm trying to do is get the best of this rotational part, but then you see that our rectangle will be really off from what I need, but maybe this has been created on purpose, and I'm going to leave it as it is for now, and I will start my reconstruction. In order to do our reconstructions, the best way is to create different bodies, and these bodies then you can use the Boolean operations. The first one I'm going to create is the handle. How we can do this is by using our sketching tools. I'll create until sketch, and I'll orient it in the right orientation, and then you can easily just move your section place into the direction that it's defined. Just my goal is just to try to get a cross section here that will be good enough for me to create my solid body. I can choose whether this should be just here or on a different position, or you can even use our stacked sections that will allow you to extract multiple sections and put them in the same location. But for now this is good enough. I just picked somewhere on the middle. This defines a good profile for me enough, and I can press create. The software automatically will turn into the sketch mode. You can always just show your mesh so you can see a visual reference. What I'm trying to do is just to create the outer part, and it has been created by a circle, and then it has 45 degrees lines here. I'm going to use, I will just turn off the coordinate system for now so you can see. I'm going to use our extraction tools. I can use the fit circle command. The way it works, you can just brush over the segments and it automatically will fit a circle. For example, I can brush here. When I leave my mouse, it just creates the best fit circle. Unfortunately, this is not good enough. I can press undo, and what I'm going to do will turn off the instant fitting. How it works, you just brush some of the areas, and this is my circular shape, and when I'm ready I can just choose create a circle of my pre-selected points. Also we have an option which is called rectangular fit. So you can just pre-select the 4 sides of the rectangle, like this one, and then you can select fit a rectangle. So this is technically what I need for my sketch. I can just go back. What I'm going to use now is what we have as a trim entity tool, which is very well known in the other CAD packages. And I'm just getting rid of the segments that I don't need simply by holding my mouse down and just brushing over the areas that I don't need. And you can see I just remove my segments which are not part of my profile. Very quickly, I'm happy with this, and I have my section sketch. I can just click on the sketch and the software will offer me whether I wanted to extrude this or create a revolved surface, or you can just right click on the sketch and select the option which is called extrude. What you see on the screen is just you can just move the 2 sides. In this case I'm just going to move it into my shape because I'm going to use Boolean operations later. The question is how far is this, and what I can use is just visually trying to get to the right position just by eye, but also what we have is something which is called the snapping tool. How it works, you in real time it just shows you where you are from the reference underlying mesh, and also when I drag, if you see there is a yellow point which snaps to the mesh, so you can pick where your end of your extrusion is and you can get the most accurate results. This is good enough for me. I can just press OK. So I created my first solid part, and I can continue with the other part which is here. I want to recreate my bigger body. The way I can do this is by using my cylinder. I will just compare, and you see that it's actually quite off now. What I need to do is to get better results, and I'm going to generate my sketch again, and I'm going to click on the cylinder and edit to see what is the diameter. So it says it's 37 point something, so definitely what I want to do is just to be 37.5 millimeters. This is my goal. This is the difference when you want to do design intent. I'm going to use what we have as a 2D sketch, which is called for revolved surface. The way it works, it takes the axis, in this case the z-axis, and when you drag it, it's actually creates a cross sections in a rotational way. This is quite convenient if you want to create revolved surfaces. This is a good profile for me, and I'm going to create this. Again, this gives us the sketch view. You can always put the mesh so you can understand what's going on. I'm going to hide my handle for now, I don't need it, and I'm going to start reconstruction of this shape. I want this outer area here. I'm going again to the brush fit. In this case I will just turn the instant fit because it's good enough, and I'm going to do this. I can brush here to extract my lines. I don't really need to start the inner area at this time of my design, so I'm just going to try to recreate my outer body. As you can see, it created the lines. I can just press back, but it's in your hands to actually make the design correct. For example, you can make this horizontal, you can create these verticals, and you can define this in the best possible way for you. I can just create this as a vertical line. We noticed that our diameter was 37.5, which technically means that we need to create this with the correct radius. How I can do this? We can use our dimension tools, and I can pick this area and define this as a 18.75 to make sure that this is the correct diameter. It says that the solver is inconsistent because it cannot define this, when you have this dimension. So now I'm okay to do this, and what I need to do is actually reconstruct my complete profile so I can make a correct revolve. I'm going to start intersecting these. How it works, if you just hold the control key and when you just brush over the corners, it automatically will intersect them. If I brush them again, it actually will make even a fillet. Let's intersect these and brush so I can get this rounded. In this case, what I need is just to have this much bigger, because I will need these for the Boolean operations, and I will just try to close my sketch. How it works, I need to close this reference by holding the control, brush over, it will intersect. And now I'm ready to create my revolved profile. Click on it and create revolved surface. So this is my body here. The next step for me would be to try to recreate this shape on the outer side. I'm going to start by extracting a cylinder, and we'll use our selection tool. I pick this area which is too much for segmentation, so I can use the sensitivity tool to avoid using any fillets and things like that. So probably 1 degree. You can experiment by changing this value. I can pick other areas, or you can just use our brush selection tools. It really depends on the noisiness of the scan data, how well this magic wand works. In this case, probably it's saves me time if I just brush and pick the areas that I want. If I want to unselect, holding the Alt key will remove some of my selected areas. I created my shape here. I can just say, okay, create a cylinder for me, and I will analyze the quality. This looks good to me. But the problem, what I see here is this part is actually not exactly perpendicular. What I mean with this is that even if I make this cylinder parallel, it will be now okay, but this shape here, it's not too much, so you may want to define a different way to define this section plane, but we will accept this for now as it's good enough. I will just drag, and the way you can do is just holding the control key. You can see that I can pick the area of where my cylinder ends. I will assume that this is good enough for our purposes, and what the cylinder does, it goes into my shape. I can always just compare and analyze. I see my deviation here, but this is acceptable. Maybe I can change the diameter if I want to, but we'll assume that this is good enough for us at this stage. As I have these two objects for now, I will need to create a shape on the top that will actually remove some material. What I mean with this is I will create my revolved sketch. The question now is, if I look at from the top view, and that this is a circle, but this shape is actually a little bit different. In this case, I will just leave it on purpose, and it will differ from our original shape, but in the future, if you want, you can try to make this in a different way. So I can pick just this profile here, and we'll create a sketch. What I have is this information. I will just hold the Control Shift to fit a line. So probably this is a horizontal line. Let me just check the level of it, and then I can just pick this and create it vertical. I can use the Control to intersect the two, and then holding Control again, it will just create this nice and good fillet. Because I need a solid body, I can just extend all the way to this level, or I can just make it exactly on the origin. If you remember, this was our precise plane that we defined, and I can just move up. As you can see, QUICKSURFACE shows you a guideline, so you can always extend into the original direction. I need to close my profile. We'll just create this line. Now if I want to intersect the two, I'll go to select mode, hold the control key and brush over the 2 points. This is good enough for me, and I can create this revolved surface. Let's go back to see what we have, which is this, and our cylinder. We are almost good to go, but before we continue, I see that there is an error, because if I combine these two, this will remain. So I will just delete this combine. So probably it's a good idea that we create the bigger body first, and then we cut off this area from the final result. How can I solve this problem? I can go to my revolved sketch, double click to edit. What I need to do is just select this and delete, and holding the control key will intersect. Now this shape is better for the purposes of our design, and I can just pick these two and tell the software to combine the selected bodies. The next step will be, from this composite body, I will ask to cut from it, and I click on it. So you can see we're getting closer to what we want to achieve. You can see our original mesh, you can compare, and you can see the deviation. This is too tight. If I'm working with a 0.1, we are getting closer. Now we are off from here, just because, as I said, it really depends what is your design intent. So we created this body, and we can continue to start with the inner part of the shape. What my next step would be to actually start cutting from my created solid, so I can create the hole which is inside. How can I do this? Again, we'll use the revolved surface, and I will take this profile and we'll recreate it. Let's create a sketch. It's important to get this ridge here, and this level is important. I will just hold Control and Shift and fit this. You see it's a horizontal line. This is exactly what I need. Then this fitting this will create my level. It is your design intent how you want to create. I think it needs to be horizontal, definitely, and I need to get this vertical line here. I need to create it as a vertical. You can see that it's a little bit different, but you can create dimensions here, how much you want this to be. And I will just intersect these points, holding the control key and brushing over. What I need is to create this part out so it can remove material. Now it's your decision where you want to place this line. Definitely it's not on an angle, but you can make it vertical, and you can always come back here and change it, intersect and move it up so it goes out of the body, even more to be on the safe side. And the last thing, we'll create a horizontal line here that will close my profile. So we have this shape. We'll create a revolved surface, and we'll go back and pick the one that we have. From this one I'm going to cut this. So this is my shape now. As you can see, we are getting closer. What I need to do now is to reconstruct these ribs. This is one of the quite complex tasks, but let's try to do this. I'm going to place this in a standard position, and before I begin, I need to create this cylinder. You'll see why. I'm going to create a sketch here. We'll pick this best circle that I need, and we'll create a sketch. We'll use the brush tool to extract my circle that I need, and I need to make sure that this is precisely in the center of my rotation. You can adjust the dimension. For example, it needs to be 12 millimeters. Double click and then change this value. It will make now your circle exactly 12 millimeters. And I'm going to extrude. I'll turn off the snapping so it can be a bit longer. This I will need later. Also, what I will need is just take this shape and we'll create a primitive, which is a cylinder from this cut face. We'll hide the main body and we'll leave this as it is now. I will bring my mesh and I'm going to try to reconstruct one of them, and then we'll create a pattern to build different solid bodies. And for doing this, I will just use our 2D sketch, but not for revolve, but for extrusion. Put it in standard view. I need to take this as a my information. Will turn the section plane in the right orientation and just slide it to get this profile here. Press create. So this is my profile, and I need to quickly recreate. Hold Ctrl Shift to extract this line, hold Ctrl to intersect and get this rounded. I can move this and put it a little bit in, and this is my first profile, and press OK. Now, in fact, I actually had to close them, double click, and just using the normal line, just connect these two. Press OK. Showing back the mesh, put it in the standard view. I'm going to create another sketch, which will pick the end of this rib, which is here, and press create. Using the Ctrl Shift, I can define. With the Ctrl intersect with another Control, it will just get this, and then I can probably just pick and create a line from the other reference sketches. It's just a visual snapping. Then I can just Control to intersect. This is not mandatory, but it just will create a good sketches. Now I have these two. What I need to do is a little bit more go back from my original body. I need to pick the bottom plane here and recreate it by constructing primitives, create a plane from selected cut model. I will need this for the purposes of trimming. Let's expand this a little bit more. I will need even to take my cylinder, which is this one, and increase the diameter so it got into my solid body. The reason for this is that when we reconstruct this rib, it needs to get nicer inside, so the Boolean operation works properly. Hide the mesh and start building my rib. We are doing this by selecting the surfacing and loft. I can just pick the two profiles that will define my rib, and I can just expand this as long as I need. For example, 3 millimeters. I make sure that it's outer and it goes into this cylinder, so it's good enough for me. Then I can press OK. What I'm going to use now is what is called the trim command. I will just select everything and select the trim. The software creates this mutual trimming and creates a lot of surfaces, so by clicking on the screen you can just get rid of what is not needed. As you can see, I'm just trying to build my solid body here just by removing everything. This indicator shows you that there are a lot of surfaces, so your goal is just to leave the ones that will form your solid body. And if you notice, when I click here, it just says solid body. My body is good enough and I can press OK. Let's see what we have done. This is our shape that we can use in our reconstruction. Now, logically, the next step would be to take this shape and go and create a circular pattern. In this case, I know it's 24 instances. I can apply it to see the result. And then I can press OK. Now it created all my ribs, and I'll hide it for now. And this is my shape, it's the pattern. Then I can save it just in case and can bring back. And what I need to do is just select everything and ask the software to combine all the bodies together. Now you can see that the combine says that it's solid body, so it's properly created, and we managed to create this shape. If you remember, we created the handle. I can just show my second option of the object tree that will give you just the top level, so you can always see what you have created. Our cylinder was as a reference. These first three, actually we don't need them anymore. Right click and delete. And I can just bring in my handle. My logical step would be just to select everything, and we'll combine them into a single body. Step by step we are getting close. Let's see, what we need to do here is to create a fillet. How we can create this fillet is by selecting the body and select the command fillet from the quick menu or the fillet from the main toolbar. The software asks us to select an edge that we want to do a fillet. One great thing about QUICKSURFACE is that it allows you interactively just to move and define the fillet, but also you have the option which is called tolerance. This will give you a good indication how close you are. For example, in real time I can just move and figure out what actually the fillet should be. In this case it's 1.16. I can probably put it 1 millimeter. Maybe this is good enough. I can just press OK, and I'm still within a good tolerance, which means that I can just leave something which is logical for every manufacturer. When I'm happy with this, I can just press OK. So we are done with the most complex problems, to be honest. Now what we need to do is just to cut off from the base. How we can do this with let's try it with this, another simple extrusion. I will just create a 2D sketch, just drag it to get this shape here, and we'll create my extruded sketch. Going to the brush tool, we'll fit a circle, and I can go back. I see that it's a little bit off, so it's your decision, but we want to be as good as possible, so I'll just keep it as it is for now. We'll bring the mesh and we'll create my extruded surface. What my goal is to cut this from my main body. I can just move this top plane wherever I want, but if you remember, I can turn off the snapping, and when I move, it automatically will just pick a point from our reference mesh. For example, if it's picked here, this is where it will snap. You can change this option to 0.05 millimeters, so you can see how good your approximation is. So let's leave it here, and then I can press OK. Now I can bring my main body, and from this main body I can cut this shape and press OK. We'll carry on and we'll cut this quad. How can we do this? Create another sketch, pick one of the profile which best describes it. Let's say it's this one. I will create it. You see that it's really a little bit off of what I would expect, but probably this is the goal. So I'm going to the select points, and I will choose select rectangle. Just brush the four sides like this one. It will create my perfect rectangle. Go back. Of course, you can draw your rectangle yourself in the perpendicular way, something like this. Now everything will be horizontal and vertical. But for the demonstration, I just show you what you can do in our software. I will just create extrusion. In this case, I don't need the snapping. This just goes all the way through, and press OK. Bring my body, and from my main body I will just cut this extruded. Getting close. What else we need to do is a few more holes here. I can just place it in the standard view. We'll create a sketch, and in this case you can visually, let's create a sketch here. I can bring in the reference mesh. Now it's in your hands to decide how you want to do this. I'm using something which is called add circle by 3 points, so I can just pick the 1, 2, 3 points, and I can just create a dimension here which is 6.6 millimeters. I will leave it as an extruded surface for now, because what I need to do to finish my project is to create this profile that it goes into. Let's hide this for now. We'll create another sketch, which is here. I'm trying to get my profile here. Again, this eventually happens to be in your hands, how you want to create this cut in. I'm going to create a sketch. This is my shape, so you can see. This is actually what I need. For example, you can clean up your reference. If you just don't need them, you can just select the clean up reference, so you can get a better understanding of the sketch. Bring back the mesh to see what's going on. Now I'm going to use the fit circle command. We'll turn off the instant edit fitting, so I can just pick more points, something like this one, and then I create my circle. I can do probably the same, or to be precise, I'll just leave it as it is now, go back, and we'll create my circle manually, so everything is under design intent. But as you can see, this doesn't work. You know, the centered are not exactly what I expect, so I'm going to fit my circle to be in a best way, like this one, and press back. I need to create a couple of lines here. Instant edit. This is my line, and this is my line. I'm going to extend them easily. I'm not really worried because I have these reference lines that it snaps, so even if I move it, there will not be a mistake. So I'm putting this larger, like this, and I'm using our trim tool to get rid of the portions that I don't need, and this will be my shape. Just drag with holding your left mouse down. My last thing is to define these ribs here. Unfortunately, I don't have information, so I will just create it with our rectangle tool, something like this. I'll get it on the other side and we'll do the same. And using again the trimming tool, we'll try to make a closed profile that is valid for the extrusion. So this is, let's assume that this is my profile, then I can press OK. What we have here, our last result was this body. I'm going just to create an extrusion. In this case, the top plane can go wherever I want, and placing the standard views. This cut inside, it's really your decision where it needs to be. I'll just leave it here. Now from my main body, I will just tell the software to cut the shape that we created currently and press OK. One last step that we need to do is from our main body just to drill a hole by selecting this extrusion. And our project is completed, and this part can be exported as a step file, and the results, you can export this as a step file. You can either map the Z to Y or not, just normally I leave it as it is, and you can send this to the printer for printing. I hope this video was useful. Thank you for watching.